Welcome back to Infinity Beyond. In tonight's journey, we venture not just across space, but into the very fabric of reality itself. We explore the strange, beautiful, and mind-bending phenomena that defy common sense: black holes, time dilation, and the mysterious possibility of wormholes. Let's begin with the most enigmatic giants in the universe: black holes. A black hole forms when a massive star collapses under its own gravity after a supernova explosion. If the core is heavy enough, typically more than 3 times the mass of the Sun, nothing can stop the collapse. The star is crushed into an infinitely dense point known as a singularity, surrounded by a region called the event horizon, the point of no return. Inside the event horizon, gravity is so powerful that not even light can escape. Hence, black holes are invisible. But we can observe their influence: stars spiraling around them, light bending near them, and powerful X-rays emitted by gas heated as it falls in. Some black holes are stellar mass, just a few times the mass of the Sun. Others, like Sagittarius A at the center of our galaxy, are supermassive, with millions or even billions of solar masses. How they form is still a mystery, but they lie at the heart of nearly every galaxy. In 2019, astronomers captured the first direct image of a black hole, not the black hole itself, but its glowing halo of superheated gas in the M80 galaxy, 55 million light-years away. It was a moment of history, a shadow in the light, proving Einstein right once more. Speaking of Einstein, it was his general theory of relativity that revealed the true nature of gravity, not as a force pulling objects together, but as a curvature of space and time. Imagine space-time as a flexible fabric. Massive objects like stars and planets bend this fabric, and smaller objects follow those curves. A black hole is a point where the fabric is stretched infinitely, a tear in the geometry of the cosmos. This curvature doesn't just affect space, it affects time. The closer you are to a massive object, the slower time passes for you compared to someone farther away. This phenomenon is called gravitational time dilation. Near a black hole, this effect becomes extreme. From the outside, time appears to slow to a crawl at the event horizon. But for someone falling in, everything feels normal until the end. This idea was famously explored in the film Interstellar, where a planet near a black hole experiences 7 years for every hour that passes on Earth. While fictional, the science is sound. Time is not fixed. It flows differently depending on your position in space and gravity. Now imagine bending not just time, but space as well. So much that 2 distant points touch. This is the concept of a wormhole. A wormhole, or Einstein-Rosen bridge, is a theoretical tunnel through space-time. If they exist, wormholes could connect 2 separate regions of the universe, or even 2 different times. Travel through one end, and you might emerge across the galaxy, or in the distant future. Wormholes are allowed by Einstein's equations, but there's a catch. They require exotic matter with negative energy density to stay open. Without it, the tunnel would collapse instantly. We've never observed such matter, and wormholes remain speculative, tantalizing but unproven. Still, physicists study them seriously. If stable wormholes were possible, they could revolutionize travel, communication, even our understanding of causality and time itself. They are at the intersection of science and science fiction, where imagination drives inquiry. At the heart of these mysteries is the question of information. When something falls into a black hole, what happens to its information? Does it vanish forever, violating quantum mechanics? This is known as the black hole information paradox, one of the deepest puzzles in theoretical physics. Recent research suggests that information may not be lost, but encoded in the event horizon, or perhaps radiated away in what's known as Hawking radiation, a quantum process predicted by Stephen Hawking. This radiation causes black holes to lose mass and eventually evaporate over eons of time. Imagine this: a black hole, once a ravenous monster, slowly fading away until only a whisper of its existence remains in the cold, dark future of the universe. As we contemplate these extremes, we're reminded that the universe is not just strange, it's stranger than we can imagine. It stretches the limits of our understanding, bends our perception of time, and challenges the very nature of reality. But it also inspires. Black holes are not just cosmic vacuums, they are laboratories of gravity. Time dilation is not just a curiosity. It's been measured by satellites, GPS, and atomic clocks. Wormholes may be unproven, but their study drives breakthroughs in mathematics and quantum theory. These are not fantasies. They are doorways to deeper knowledge, and possibly one day to other parts of the cosmos. As this segment closes, let's pause, floating in quiet awe at the edge of a black hole. Space curves around us, time slows, and in the silence we feel something profound, the pull of wonder. This is Infinity Beyond, where science and dreams collide in the gravity of the universe. Welcome back to Infinity Beyond. We've soared past planets, stars, galaxies, and even black holes. But tonight, we look ahead, not just into space, but into time itself. What happens when the stars go out? What becomes of a universe that keeps expanding? This is the story of the end of everything. Let's begin where we are now, in a universe still full of light. Stars shine, galaxies dance. Life exists, but it's only temporary. Even now, the universe is changing, expanding, cooling, aging. Our sun, like all stars, is not eternal. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, swallowing Mercury and Venus, and possibly Earth. After that, it will shed its outer layers and become a faint, cooling white dwarf. Other stars will follow similar fates. The massive ones will explode as supernovae, leaving behind neutron stars or black holes. Eventually, the universe will enter a new era, the degenerate era. This is a time where no new stars are born. The galaxies dim. Only the embers of the cosmos remain. White dwarfs, neutron stars, black holes. Over trillions of years, even white dwarfs will cool into black dwarfs, invisible corpses of once bright suns. The skies will go dark. But it doesn't end there. These remnants will continue to interact, slowly losing energy through gravitational radiation. Planets will drift away. Stellar remnants may collide, creating momentary flashes. But overall, the universe becomes quiet. In 40 years, a number so vast it's nearly impossible to imagine, black holes will dominate. They'll be the last energetic objects in the universe. But even they are not forever. According to Stephen Hawking, black holes slowly emit Hawking radiation and lose mass. Over unimaginable timescales, they shrink and eventually evaporate completely. One by one, the black holes will vanish. When the final one disappears, the universe will enter the dark era. No stars, no light, no structure. Just an ever-expanding fog of cold particles, protons, electrons, and photons drifting endlessly. The cosmos, once so alive with energy, will become a frozen sea of nothingness. This is called the heat death of the universe. In thermodynamics, heat death refers to a state of maximum entropy, when all usable energy has been evenly distributed. There's no difference in temperature, no gradients to do work. The universe becomes thermally balanced and utterly lifeless. Time still moves forward, but nothing changes, nothing evolves. It is the ultimate stillness, but heat death is only one possible ending. Another theory is the Big Crunch. If the universe's expansion were to reverse, due to gravity overcoming dark energy, all matter and energy could collapse back into a single point. The universe would shrink, heat up, and potentially lead to a new Big Bang. A cyclical cosmos, forever rebirthing itself. But current data suggests expansion is not slowing, it's accelerating. That leads to another possibility, the Big Rip. In this scenario, dark energy becomes stronger over time. Galaxies are pulled apart, then stars, planets, even atoms. Eventually, space-time itself is torn asunder. Everything is ripped apart, including the fabric of reality. This cosmic ending would be violent, fast, and final. But it hinges on the nature of dark energy, which remains mysterious. Is it constant? Growing? A temporary phase? We simply don't know. And then there's the most speculative idea of all, that our universe is not the only one. Some physicists propose that the Big Bang may have been a quantum event, a fluctuation in a larger multiverse. If so, our universe might be one bubble among many, each with its own laws of physics, its own beginnings and ends. In this multiverse, the end of our cosmos might not be the end of everything. Other universes could be forming right now, blooming like flowers across a cosmic landscape. New Big Bangs, new physics, new possibilities. And here's something even stranger. Even nothing may not be empty. Quantum mechanics tells us that empty space seethes with virtual particles. Particles that blink into existence and annihilate in a flash. If space can never be truly empty, then maybe the seeds of creation are always present, waiting for a spark. Some theories even suggest that from the vacuum of a dead universe, a new universe could be born, a rebirth from the ashes of heat death. So, is there truly an end? Or is the universe a cycle of beginnings, expanding, cooling, collapsing, rebirthing, forever? We don't know the answer, but the question matters. It connects us to something bigger than ourselves. It reminds us that we are part of a cosmic story, with a past, a present, and a destiny. As Segment 7 comes to a close, we rest at the edge of eternity. The stars fade, the galaxies dim, and yet we are still here, dreaming, asking, wondering. This is the gift of science, not certainty, but curiosity. Not answers, but exploration. This is infinity beyond, and though the universe may one day fall silent, our fascination will echo forever. Welcome back to Infinity Beyond. So far, we've explored distant galaxies, fallen into black holes, and watched the universe fade into darkness. But tonight, we turn inward. We explore something equally vast, equally mysterious: consciousness. The universe is filled with stars, gravity, radiation, and particles. But for at least one brief moment, on a small blue planet orbiting an average star, it also contains awareness. You. You are not just observing the cosmos, you are part of it. And more than that, you are the part that can ask questions. So, what is consciousness? And why does it matter in a cosmic context? In simple terms, consciousness is our ability to be aware of the world, of ourselves, of time, of thought. It's the voice in your mind that says, I am. It's your window into the universe. But where does it come from? The human brain is made of matter, atoms forged in stars. It's a network of neurons and electrochemical signals. And yet, from that physical structure arises something intangible: thought, feeling, memory, identity. This is known as the hard problem of consciousness. How subjective experience emerges from physical matter. Science can map the brain. It can identify regions responsible for vision, emotion, decision-making. But how do those patterns give rise to awareness? Why does a brain not just process data like a computer, but actually feel? We don't know. Some scientists propose that consciousness is a byproduct of complexity. When a system becomes sufficiently intricate, awareness emerges. Others suggest it may be more fundamental, perhaps even a property of the universe, like space or time. This idea is known as panpsychism, the theory that consciousness is not unique to brains, but exists in some form throughout the cosmos. Not that rocks are thinking, but that the basic spark of awareness is embedded in all matter. It's a controversial idea, but consider this. The same atoms that make up stars also make up you. The carbon in your DNA, the calcium in your bones, the iron in your blood, all born in the hearts of ancient suns. You are literally made of stardust. But more than that, you are the stardust that thinks. This idea was beautifully expressed by astronomer Carl Sagan. We are a way for the cosmos to know itself. Let that sink in. For billions of years, the universe evolved without eyes, ears, or thought. Just stars forming and dying, galaxies colliding, planets orbiting. Then, something changed. On Earth, chemistry became biology. Biology became consciousness. And now, consciousness looks back at the stars. In a way, you are the universe dreaming of itself. This perspective changes everything. It reframes life not as an accident, but as a natural flowering of the cosmos, a continuation of the same process that creates stars and planets. And while we may be small in scale, our ability to ask questions, to wonder, gives us immense significance. When you gaze at the night sky, you're not just looking out, you're looking in. Because the same forces that govern galaxies also shape your thoughts. The same quantum rules that describe photons also underlie your neurons. In some mysterious, poetic way, there is no boundary between the observer and the observed. You are part of the equation. And so, we arrive at the question, why does the universe allow consciousness at all? Some physicists believe the universe must be just right for life and consciousness to emerge. This is known as the anthropic principle. Others suggest we live in a multiverse, and we happen to be in one of the rare universes where conditions allow for observers. But maybe it's simpler. Maybe consciousness is not a glitch in physics, but a feature. Maybe awareness is what the universe does when it becomes complex enough. Stars explode, planets cool, life begins, and eventually something stares back at the sky and says, I am. In that moment, the universe becomes more than physical. It becomes personal. And so, in the grand scale of time, in a universe that may end in cold silence, consciousness might be one of the most precious phenomena to ever exist. Because only consciousness can give meaning. Only awareness can love, create, reflect, and remember. The universe may not care, but you can. And that might be enough. As Segment 8 closes, let's sit in stillness, not at the edge of a galaxy or a black hole, but within our own awareness. Feel your breath. Feel your heartbeat. Feel the quiet presence of being. In this silence, something profound is revealed. You are alive. You are aware. And in a cosmos of endless space and time, that matters. This is Infinity Beyond, where stars and self meet under the banner of wonder. Welcome back to Infinity Beyond. After exploring the origins of consciousness and our place in the cosmos, tonight we turn our gaze outward again, not to stars or black holes, but to one of the most profound questions humanity has ever asked. Are we alone in the universe? For millennia, humans have wondered if there is life beyond Earth. Ancient civilizations looked to the stars and imagined gods, spirits, or distant worlds filled with beings like or unlike on us. Today, science gives us tools not only to imagine, but to search. It begins with exoplanets, planets that orbit stars beyond our solar system. The first confirmed exoplanet around a Sun-like star was discovered in 1995. Since then, we've found over 5,000 others. Some are massive gas giants, others are small and rocky. Many orbit in what we call the habitable zone, the region around a star where temperatures could allow for liquid water. Water is key because, as far as we know, it's essential for life. But life, especially alien life, might surprise us. Among the most exciting discoveries are Earth-like exoplanets. Take Kepler 452b, for instance, a rocky planet in a habitable zone, orbiting a star much like our Sun. Or TRAPPIST-1, a system with 7 rocky planets, 3 of which lie in the habitable zone. A single system, just 40 light-years away, could potentially host multiple life-bearing worlds. And yet we have found no evidence of life, no signals, no biosignatures, no visitations. Why? This silence is known as the Fermi paradox. Physicist Enrico Fermi famously asked, "Where is everybody? With billions of stars, billions of planets, and billions of years of cosmic history, intelligent life should be common. So why haven't we seen it?" There are many theories. One possibility is that life is rare. Perhaps the conditions that allowed it to arise on Earth are incredibly unique. Or perhaps life is common, but intelligent life is not. Evolution doesn't guarantee curiosity, technology, or communication. Another theory is that civilizations destroy themselves. Once they develop advanced technology, they may trigger their own collapse through war, climate change, or artificial intelligence. This is sometimes called the Great Filter, a stage of development so dangerous that few civilizations survive it. If we haven't yet passed the Great Filter, it may lie ahead. But if we have passed it, we might be among the few or the only to emerge on the other side. A more optimistic possibility is that intelligent life is out there, but we just haven't found it yet. Maybe they use technologies we can't detect. Maybe their signals are rare, brief, or too weak. Or maybe they are watching silently, waiting. To search for alien life, we use several tools. One is SETI, the search for extraterrestrial intelligence. SETI listens for radio signals from distant stars, hoping to catch a whisper from another civilization. So far, it's found nothing definitive, but the silence is not discouraging. It only deepens the mystery. Another is the study of biosignatures, chemical fingerprints of life. When we analyze a planet's atmosphere, we look for gases like oxygen, methane, or carbon dioxide in the right balance. These could indicate biological activity. Future telescopes, like the James Webb Space Telescope and others beyond it, will help us scan exoplanet atmospheres more precisely than ever before. One day, we may look at a distant world and see signs of life written in its skies. And there's more. The study of extremophiles on Earth, organisms that thrive in boiling acid, deep-sea vents, or frozen Antarctic lakes, shows us that life can exist in conditions once thought impossible. If life can adapt here, why not elsewhere? We also search our own solar system. Mars has ice. Beneath the crusts of Europa and Enceladus, moons of Jupiter and Saturn, lie vast liquid oceans. NASA's upcoming missions aim to explore these worlds directly, searching for microbes in their subsurface seas. Even Titan, Saturn's largest moon, with its lakes of liquid methane, challenges our assumptions about life's possibilities. It may host a form of chemistry we don't yet understand, an alternative biology unlike anything on Earth. And then there's the Drake equation, a formula proposed by astronomer Frank Drake to estimate the number of active communicative civilizations in our galaxy. It multiplies factors like star formation rate, fraction of stars with planets, number of habitable planets, probability of life, and more. While many values are still unknown, the Drake equation reminds us, Even tiny probabilities, multiplied across a galaxy of 400 billion stars, can yield surprising results. So, are we alone? We don't know. But the search itself is meaningful, because in seeking others, we learn more about ourselves. We refine our understanding of life, chemistry, evolution, and consciousness, and we begin to see Earth not just as home, but as one possible world among many. Whether the universe is filled with life or we are the only ones, either answer is profound. If we are alone, life is even more precious, a cosmic miracle. And if we are not alone, we are part of a grander story, one still unfolding. As segment 9 comes to a close, we look up not in fear or loneliness, but in hope. Hope that the universe, in all its silence, may still be whispering. That on some distant planet, under an alien sky, others are asking the same question. This is Infinity Beyond, where science searches not just for stars, but for companionship among them. Welcome back, one final time, to Infinity Beyond. Over the past 9 segments, we've traveled through planets and stars, nebulae and black holes, the birth of time, and the edge of its ending. We've wandered light years away from home, and yet somehow we've ended up right here, in ourselves. Tonight, we slow down, not to learn, but to reflect. Not to explore, but to simply be, aware, awake, present in the vastness. So close your eyes if you wish. Let go. Let this be a gentle meditation, a cosmic lullaby, a whispered truth. We are travelers, not just of space, but of meaning. In the beginning, there was no light, only a singularity, a potential, a breath waiting to be taken. Then the Big Bang, and from that breath, the universe expanded. Time began, space stretched, stars ignited, and galaxies spun their arms wide into the dark. All this to one day allow life, to allow you. Atoms collided, stars died, elements formed, Earth took shape, water pooled, molecules danced, and after 4 billion years of trial and error, something extraordinary happened. Consciousness opened its eyes. You are that spark, that fragile, fierce flame of awareness, a collection of stardust arranged in such a way that the universe could finally look back at itself and wonder what it all means. You are not apart from the cosmos. You are of it. You are not small. You are not lost. You are exactly where you belong. Because what could be more cosmic than a being who dreams? The vastness of the universe isn't meant to make you feel insignificant. It's meant to awaken your sense of belonging. The same gravity that binds galaxies flows through you. The same quantum rules that govern particles dance inside your cells. You are made of the same elements as the stars, the ocean, the sky. You are the sky, learning to breathe. You are the ocean, learning to feel. You are the stars, learning to love. And in this life, this one brief flame between stardust and silence, you get to be awake. You get to see the world, to ask questions, to feel the chill of wonder and the warmth of awe. That is no small thing. Perhaps that's the meaning, not to conquer the universe, but to understand it. Not to master it, but to appreciate it, to witness it, to cherish it, and to leave it better than you found it. The night sky is not a wall. It's a mirror. It reflects back everything we are and everything we might become. When we gaze at Saturn's rings, we see beauty. When we explore Mars, we see possibility. When we listen for signals from distant stars, we hear our own longing. In the silence between galaxies, we meet our oldest friend, mystery. And in the final flicker of a dying star, we remember, everything ends. But in that ending, something new begins. We are all stories. We are all echoes. We are all travelers, briefly passing through the light. So let us not just look to the sky with questions, Let us live like answers, with kindness, with courage, with wonder. Let us build telescopes and relationships. Let us launch rockets and compassion. Let us explore the stars and the human heart. Because the universe is not just out there. It is in here, in our thoughts, our hopes, our connections. As segment 10 ends, and with it this journey, remember, there is no final frontier. There is only the next question, and the next star, and the next heartbeat. This is Infinity Beyond, and though this chapter closes, your journey continues.